One of the things we've learned through the history of looking at the sky is that every time you look in a different way, you see new things. And looking at the sky a different way often simply means looking in a different part of the electromagnetic spectrum. As we look up into the sky with our eyes or with the aid of optical telescopes, in the visible part of the spectrum, we see the night sky, and there's a lot to see, but it's only a fraction of what's out there.
Some space telescopes see through cosmic dust with infrared vision, similar to that used by commercial infrared cameras.
I've brought with me this plastic bag, and when I put my hand inside of the bag, you can't see how many fingers I'm holding up. With the infrared camera, you can see the heat coming off my body. So my face, which is warm, is red and white, but my hair, which is cool, shows up as blue. So with the infrared camera, you should be able to make out how many fingers I'm holding up, even though you can't see through this bag. That's how astronomers peer through cosmic dust when they want to see things that are hidden from sight. For example, stars being born are very warm, but they're obscured by dust shells. With infrared, we can see them.
Certain objects are transparent or opaque depending upon the frequency of the light that's trying to get through them. And so, in fact, something that's getting in the way, like a lot of interstellar dust or gas, is getting in the way of what your telescopes can see, are actually invisible in another part of the spectrum. You can see what's behind.
With infrared and a multitude of other wavelengths at our command, we've discovered a lot of neighbors we didn't know we had.
There's a whole array of instrumentation which is exploiting that lesson that if you look in a particular part of the spectrum, you see the sky in a very particular way.
From what we've observed, it looks like some old neighbors might have helped life form on Earth, while some newer neighbors may be planning to wipe us out. As we've explored our place in the Milky Way, we've met a lot of interesting new neighbors. But there are good neighbors and bad ones.
Good neighbors are, for example, objects that are in predictable orbits, moving around, doing their own thing, minding their own business. We can look over and wave to them, but they're not going to do something sudden or dangerous to us. The bad neighbors then would be things that may do something unstable. They may do something that could affect us in a way that we can't predict when it's going to happen. So that might be when a star dies and explodes. Or it might be when something collides and bounces off something else and comes spinning in our direction. So classifying things roughly into good neighbors and bad neighbors is really a classification into predictability and unpredictability, or violence and non-violence, if you like.
Sometimes a good neighbor will bring a moving-in gift. That might have happened to us billions of years ago, as the Earth was still cooling and forming out of recycled material from a recycled sun. We might have received a gift that changed everything.
The early Earth was very hot, and probably any original surface water evaporated away. So we think that quite a bit of the water may have come from either comets or icy asteroids, or both.
One of the theories about how we might have gotten so much water here on Earth is from icy bodies in the outer solar system left over from the formation of the sun and the planets, crashing into our inner solar system where Earth lives and delivers some of that water.
According to one recent theory, about 4 billion years ago, the gravity of gas giants like Jupiter sent icy asteroids slamming into Mars, Earth, and Venus. But only on Earth did the ice penetrate into the mantle. The water softened the Earth and initiated a titanic process of plate tectonics, which led to the emergence of continents and oceans. And what of the life that formed in the oceans? Did organic compounds necessary for life also splash down from space? In rare meteorites called carbonaceous chondrites, scientists have found organic compounds like those that helped form life on Earth. These compounds are similar to what's been collected from many different sources, including Antarctic micrometeorites, interstellar dust, and comet samples acquired by NASA's Stardust mission in 2005.
The origin of life involves a long series of reactions with many different organic molecules being just ones with carbon in them. And it's possible that different circumstances are needed to make the different organic molecules. Some of them might be made here on Earth, but others might be easier to make out in space and then bring them here to Earth on asteroids or comets.
It's possible that without extraterrestrial gifts from our neighbors in space, life on Earth might never have happened. Milky Way neighbors may have helped nurture us, but the Milky Way has things that can kill us as well. With something like this, an orange dwarf named Gliese 710. It's about 60% as massive as the Sun and is currently just 63 light-years from Earth and getting closer.
Gliese 710 appears to be heading pretty much straight toward the solar system.
As an orange dwarf approaches the solar system, it becomes more and more significant. When it's about a light year away or less, then it becomes very important.
Almost exactly 1 light-year away from Earth is a huge region of icy objects called the Oort cloud.
The Oort cloud objects could turn into comets if they were to come close enough to the Sun, but usually we don't see them at all because they're so far away from the Sun.
Billions of potential comets are waiting for something to give them a gravitational push. Something like Gliese 710.
It'll start intersecting the Oort cloud, or at least gravitationally disturbing it, in something like 1.3 million years.
If Gliese 710 gets close enough, its gravity could turn harmless chunks of ice and dust into rampaging comets launched at us. The results for Earth could be devastating.
At that point, there could be a huge onslaught of comets into the inner solar system that could lead to another mass extinction. We don't know that that'll happen, but it could happen.
Astronomers say there's an 86% chance that Gliese 710 will barrel right through the Oort cloud.
So if the orange ball was like an orange dwarf, like Gliese 710, and the pins were the Oort cloud, this is one thing that could happen.
All right, but here's something else that could happen. There's a 14% chance that Gliese 710 is just going to pass right by outside the Oort cloud, not coming inside it at all.
But even without a direct hit, the effect of the star's gravity could disrupt at least some comets and send them straight for us.
So the star could knock just a few comets toward the inner solar system.
And all it takes is one comet to hit Earth to cause a catastrophe.
We've got more than just Gliese 710 to worry about. There are more than 150 stars close enough to disturb us within the next 2 million years.
The stars in our Milky Way galaxy are all gravitationally bound together. So they're moving in various directions, overall a rotation around the center of our galaxy, but not all the orbits are exactly the same. That means from our perspective, a given star might be going away from us or toward us.
And NASA estimates there are more than 20,000 near-Earth asteroids more than 300 feet across. Like 2005 YU-55, which in November 2011 came closer to the Earth than the Moon. It might come even closer in 200 years. How bad would it be to get hit by a rock like that? Think about Nagasaki at the end of World War II and multiply by 4. As we've searched our corner of the Milky Way for other neighbors, bad and good, we've found some very unexpected things. We now have evidence of stars cold enough to touch and planets straight out of science fiction. Exploring our place in the Milky Way has turned up one surprise after another.
It's like there was a house in your neighborhood that you never knew was there and that you've suddenly discovered, but is just down the block.
Take Alpha Centauri, the brightest star in the constellation Centaurus, and after the Sun, our nearest neighbor star, 4.3 light years, or 25 trillion miles away. In the 17th century, astronomers announced that Alpha Centauri was really 2 stars. Then in the 20th century, it turned out to be a triple system.
Alpha Centauri A is very much a Sun-like star, nearly exactly the same mass as our Sun. Alpha Centauri B is a little bit less massive. The third star, Proxima Centauri, is an M-type star. It's a very low-mass star, having perhaps only 12% the mass of our Sun. It is so faint that we can't see it with our unaided eye.
It turns out that other very well-known neighbor stars are also multiple systems. Sirius, just 8.6 light-years away and famed for thousands of years as the brightest single star in the sky, is really a binary star.
Heads is the most complex arrangement of matter in the known universe.
You might ask yourself, can we get to be superhumans?
The original Industrial Revolution was driven by the discovery that you could use steam engines to do all kinds of interesting things.
But that was followed by additional revolutions for electricity and computers and communications technology. We're now in the early stages of the 4th Industrial Revolution, which is bringing together digital, physical, and biological systems.
One of the features of this 4th Industrial Revolution is that it doesn't change what we are doing, but it changes us.
With the ability to visualize brain activity, for example, through a simple consumer-based EEG device, it gives us access to ourselves in ways that we've never before thought possible. It unlocks the black box that is the brain and enables us to really, truly be able to realize an identity that is aspirational.
There's now a scientific foundation for the effects of mindfulness on the brain, on the genome, on biological aging. And when the human mind does know itself, then you get the potential for a new renaissance that restructures itself in terms of our relationship to life, our relationship to the planet, our relationship to work.
We need a different economic model. And by that I don't mean capitalism versus communism. What I'm talking about is a shift in the system along the lines of the 2 big changes that happened in the 20th century, Keynesianism, with a much greater focus on health and education and the role of government working with business, and then a reaction against that in late century to neoliberalism, where the focus was on free markets, freedom of the individual, and getting governments out of the way. We need a shift to a new system that will allow